See that? So yeah,
Is it
we're
further?
live with Mr. John Akinode. Um, yeah, Mr. Akinode is so much involved in coding and robotics with kids in Nigeria, and it's done a whole lot. So from doing boot camps to doing uh, organizing sessions after the school year. So this is Mr. John Akinode, and he's going to be presenting on his perceptions of children learning with boot camp and all of things. So welcome, Mr. John.
Thank you very much. I
Yeah,
want to believe you can see my slide, right?
yeah, we can see it. You can go ahead.
Okay. So good evening, everyone. My name is Akinode John, and I'm presenting the paper titled Children's Perceptions of the Effectiveness of Online Coding as a Supplement to In-Person Bootcamp. The paper is written, is co-authored with Olorun Tobayese uh, from the Department of Computer Science, Federal Polytechnic Ilaro in Ogun State. Let me speak briefly about myself. I'm a software developer. I'm a state education advocate and also a lecturer at Department of Computer Science, Federal Polilaro in Ogun State, Southwest Nigeria. Also, in a lighter mood, I'm a jollof rice ambassador. And also, I'm the founder of Little Coders Nigeria, and I live in Southwest Nigeria. Yeah, let me speak briefly about my journey into coding. I developed interest in taking kids coding sometime in 2016. One of the reason for starting this is because of I discovered that as a lecturer, when students when they are newly admitted to the department, I discovered that most of them I discovered that they have never heard about coding, even from primary to secondary school level. And then when they are admitted, we discover that they struggle a lot because they have not been exposed to some of the concepts of coding. So because of this, I decided to go to primary schools in my neighborhood to sensitize the school to organize training for the teachers, organize boot camps for children, and that's what I've been doing. And so far, I've trained over 5,000 kids in the little community called Ilaro in Ogun State, Nigeria. So, but this year, because of the pandemic, we are unable to have our face-to-face class. So we decided to go virtual. And that is exactly the purpose of this presentation. Our focus is to present our findings on the student experience or their experience in the online coding camp. We have been having the face-to-face class because of the pandemic now, because we cannot gather together in the class. The schools are shut and then so many other things. Because of that, so we have decided to use Zoom and WhatsApp for our class. Let me speak briefly about Little Coders Nigeria. Little Coders Nigeria was created to engage the innate creativity and potentials of the little ones by exposing them to coding and robotics. So, and that's what we have been doing for the past 3 to 4 years. Now, I want to talk about coding at primary school level. Presently, all over the world, or in the world generally, that there's been a clamor and campaign for coding to be taught in schools from primary school level. Similarly, private schools are also, you know, encouraging schools to teach computer science at primary school level. So coding at K8 for kids is now at the front burner for many countries of the world. Computer science opportunities in K-12 schools have increased in recent years. According to Ashley 2019, yeah, it retrieves that administrators and teachers are realizing that teaching computer science can foster important 21st century skills for learners. Some of these skills include problem solving, critical thinking, computational thinking, creativity, and collaboration. Computer programming for young children has grown in popularity among educators and product developers. What exactly is the purpose of this research work? This study investigated primary school children's performance on a programming assessment after engaging in a 5 week online coding class through Zoom and WhatsApp applications. Children used unplugged activities to solve computational thinking problems and Scratch programming tool to create animated stories and games. Now, we try to look at the effort of different countries, what they have been able to achieve in introducing coding at the primary school level. And then we discover that in the United Kingdom and some other European countries, they have successfully implemented coding at the primary school curriculum. So computational thinking and coding in education have become integral parts of the school curricula in many countries. For example, United Kingdom has integrated computer programming as a mandatory course starting from primary school, according to June 2013. Also, in Denmark also promotes digital literacy, focusing on the knowledge gained from building technologies. Now, let's see the effort of other countries, what they have been able to do in implementing coding at the primary school level. We discovered that other countries have achieved that. We have Estonia, we have Australia, I think only South Africa and in Africa, United Arab Emirates, Singapore, and the rest. Then what is going on in Africa? Presently in Africa, let me focus on Nigeria. Presently in Nigeria, at the primary school level and secondary school level, what they are being taught is data processing. In our curriculum, there is no coding in our curriculum. Like I've told you, the reason why we have graduates that are not, that don't have skill, that cannot, that don't understand programming is because they are not being exposed to it at the tender age. And that's exactly the problem we're trying to solve by going back to the grassroots, going back to primary school to expose the kids to coding. So in Nigeria present, or let me say in Africa presently, the government they have a lot of work to do to in policy, implementation to ensure that coding is implemented at the primary school level. Computational thinking, let me give this scenario. Anytime we have our boot camps, we try to implement the computational thinking in different areas. An example is once I told the kids that once you are giving an assignment, the assignment it can break it down into different components. Then you can solve one part, solve the second part, the third part. By the time you put everything together, what you have done is that you have implemented one of the concepts of computational thinking, which is decomposition. Also, we try to talk to them about algorithm, where a sequential order of activities, what you do daily when you wake up, among other things. So we use some of these, their day-to-day activities, to teach them or to explain the concept of computational thinking to kids. So this is the diagram that illustrates what computational thinking is all about. We have the decomposing, the abstraction, the pattern, and the algorithms. And the private companies are also coming up with initiative, in helping kids to develop computational thinking, with their platform. So talk about initiative for computer science education. Among the company, private companies, organizations that have been able to come up with that initiative is code.org and then Code Academy. And also in Africa also, we give kudos to African Code Week, what they have been able to do yearly with the code camp that they organize yearly in Africa. So what are the tools for teaching coding, for kids at the K8 category of primary school level? We have Scratch. Among them is, notable among them is Scratch, very popular. Scratch is there. That is Scratch JR for junior category. That is Tinker is also there. Blockly, that is code.org. That is MIT App Inventor. But let me say at this junction that there are so many tools, out there on the internet. But one of the challenges we are having in Africa, let me say from my experience, is that any internet-based, tools will normally have problem with it because of the problem of internet, problem of power and the rest. So most times we prefer, software that we can download on our system and that we can be run locally for the kids. Now, methodology. How did you go about this study? For the purpose of this study, an online coding program has been organized via Zoom clients and WhatsApp by Little Coders Nigeria in Southwest Nigeria. The workshop have been designed following the constructionist approach and its main principle, learning by doing, as done by previous efforts. The online customer coding workshops are out of school activities in which students from K education participated. Our participants are children from 6 to 12 years. And during the workshop, they learned about computer thinking using unplugged activities, and then they code their own game using Scratch programming language. The activity lasts for about 3 hours daily for 5 weeks. The parents were also involved in the workshop as they helped their kids to set up the Zoom platform and also help in assignment submission via WhatsApp and email. Now, still on the methodology, data were collected through interviews. So what we do most time is that we look at their, we know we try to get their knowledge before the program, and then after the program, the pre and the post, we interview them. One of the challenges we have been having is that once we have any program and there is a time gap, by the time they come back, they normally have issue. Some of them still struggle. We have taught them about variable. They have written program using variable, but when they come back after 5 months, they start having issues. So what I normally do most times is I will sit them down, try to interview them I'll try to know whether they see understand some of those concepts. And then also we have a rubrics that we use and then questionnaire that are served to participants, and then we get the response. Now, a sample of 50 students in primary school K8 were randomly selected. The students were examined based on their previous knowledge using normal classroom teaching and the knowledge acquired using the e-learning platform on computer thinking via unplugged activities and Scratch programming. Okay, let us see. This is an example of one of the unplugged activities submitted by one of the kids. The first one is an algorithm to describe to move from one point to another. The other one is an algorithm to describe the recipe for preparing Indomie. Indomie, it's very popular in Nigeria among kids. So we try to use stuff that are very close to them to illustrate our, the concept. So this is one of the assignments submitted by the student. So they wrote, this is an algorithm. So sequentially, they explain the recipe for preparing Indomie from step 1 to step 2. Now, and after some time, we'll try to reorder it and then to come up with an efficient recipe. And then you understand the concept of algorithm because of doing that. And there is one of the programs submitted by a student. And there is another program submitted by a Scratch programming. Like I've said, we use unplug activities and then we use Scratch programming. Now, how do we evaluate their work? Now, so then they have designed a program. Then how do we give them feedbacks? They are eager. They have submitted an assignment and they want to know whether they have done well or not. So how do we give them feedback? It depends. One of the things I've done over times is to give them a quiz. And then we have used several platforms. But I discovered that the kids, they love Kahoot. They love it so much. Anytime we want to, use Kahoot for our quiz now, they're always happy because they know they're going to use their mobile phone. And then because they see some graphics on the screen, they are always very happy, and then they are joyful. So in the past, we have used Kahoot, and then recently we tried to implement Grayscope for the assessment or evaluation for quiz. This is an example of a question that we said before. This is that is the name given to the background of the Scratch. So they answer it, and at the end of the day, we pick the winner. So most time we can give them a small gift, and then they are happy. This is Grayscope. The Grayscope was used for the last program that we had. This is the great, and then now for the project-based assignment. That is when they develop a program using Scratch. How do we evaluate the program? We use what we call Dr. Scratch. Dr. Scratch is an analytical tool for evaluating the effectiveness of Scratch project in terms of the computational thinking evidence in the project. So most time when kids when they write program, they might evaluate some of the rules. But once we use the Scratch, then they see the report. They see the area where they need to improve upon, maybe the area of use of variables, parallelism, sequential, and the rest. And then we give them feedback. This is an example of a program that was graded using or evaluated using the Scratch. So look at the computational thinking concept, the flow control, the abstraction. So this shows that something is done with this program. And then the level of your project is basic. So the student or the kids has to go back again, look at that program. Most times I'll sit them down and explain to them, okay, this is the problem. This is what you need to improve upon, and then I'll work on it together. So this is another one. This one is quite different for that one a little bit. There's an improvement here. And then development of projects, then they look at it. The flow control is not bad, but not accurate. Data representation is not bad too. And then, so this is an example of a feedback from Dr. Scratch. So this is the framework used by Dr. Scratch in evaluating the code. Now, what are the challenges facing teaching children to code in Africa, or what I've seen so far? One of the challenges we have is cost of internet. In the past, during our face-to-face class, we normally have a very large class, because they don't pay for anything. The parents are not bothered by anything. They release their kids to come for the program. Now, because of the cost of internet data, cost of power supply and the rest, and the parents are, they are having issues. Some of them they complain a lot because of that. Their kids did not, participate in the program. So also another issue we face is the poor internet service. And then also, this one is peculiar to us in Africa, incessant power supply. So most time we want to have a class and there's no power supply. So we do not have any choice than to abandon it. So how can we deepen coding education in Nigeria? The first thing is policy change. The government has to be involved. Government has to enact laws, that will encourage the implementation of coding at the primary school level. The African governments in Africa, they need to rise up, to that challenge and make sure that they come up with a good policy, in that direction. Another thing is capacity development. The teachers too. If you don't know something, you cannot teach it. That's one of the what you don't have, you can't teach. So there must be capacity development among the teachers. Most of the teachers in primary school, in secondary school, the only thing they know is word processing and Z. That's all. So they need to come, rise up to that challenges. They need to go a step further, learning about programming. Another thing I discover in most of the schools is that some of the teachers that take some of those courses, they did not have computer science background. Some of them they read something else, because they did not have anybody to teach, so they moved to it. So that's one of those things. So there must be capacity development, and also private company must be involved, like what African Code Week is doing, what Gogwe is doing, and the rest. So private companies within Africa must be involved, then to change the story. No result analysis and conclusion. The students were examined based on their previous knowledge, using the normal classroom teaching and the knowledge acquired using the e-learning platform on computational thinking via unplugged activities and scratch programming. Sample T test was used to compare the level of skill or knowledge acquired during online coding class and coding informal contest. The results show that there is no significant difference between the teaching method because the p-value is greater than 5% significance level. However, the class activities were hampered by the difficulties in breaking the participants into groups and technical challenges as a result of internet and power failure. It was concluded that both interventions improve student computational thinking skill and competency. Thank you.
So, hello. That's a very good presentation by Mr. Akinode. Yeah, and you've actually been in the space so much, and you're doing a lot of things. So now, the curriculum that you use, was it a modified thing of the ones that you collected, or you wrote a curriculum on your own that you're using for the uh, kids to learn coding?
Uh, Thank you. What we have done is to modify the curriculum from the African Code Week platform. So there is a curriculum there. So that's what we have done, and also um, from the Scratch platform, we got some materials from there too. So what I do majorly is I try to modify it and then to address problem that we are facing.
Okay,
But
that's a very good answer. Yeah. What about this? How do you uh, collaborate too? Because okay, you first of all tell us what's the average number of uh, children that come to your session, and how do you manage to arrange for it?
Are you referring to the online coding or
Um,
the
you know,
face-to-face class?
yeah, the face-to-face class, then we now talk about the online also.
Okay, for the face-to-face class, I have some guys that are working with me. So
Okay,
that's what they are around. So they are the one that help. And another thing we do is that we try to break them into two categories, the K8 and the K12. So because of doing that, some of them they are focused and then they follow the instruction.
okay. So, what about the online program?
For
Like
for the
how many?
online class, what we do is we have one in the morning, another one in the afternoon.
Okay.
That's what we do.
So, what's the capacity of learners that you've been relating with over the years? Okay,
But
specifically
uh,
during the COVID now.
during the COVID, let me say 60. But some of them will come today, they might not show up again. So the program was for like 5 weeks, but those would have consistent, say maybe 40.
Okay,
So
okay. So, what are your plans in the future from what you've been able to find out from figure out from uh, the analysis that you have done with uh, doing those programming language tutorials for students in that. So what's the future like for you?
my plan is to I want to start developing apps for kids, that they can use to learn programming. So most time they don't need to come to the program. So most of the things we have done can be, can put everything together in an app. And also I'm planning to write a book too and on coding. Like I've told you, anytime we have a program and once there's a gap and they come back, they start struggling. So they are forgetting some of the concepts that they were taught. So I believe once they have, they like mobile phones. So once I put the, you know, program in an app, so they have access to it, they can use it anytime they like. And then they have a hard copy. So even if you are not having our boot camps, but we cannot be having the boot camps we meet like two or thrice in a week in a year. So we cannot be having it every time. And another issue we are having here is that most of the kids in their school they don't have coding in their schools. So once they get to school, everything will change. So they start learning word processing and the rest. So what I believe, and I'm also trying that here to help school to set up a club and most of them the kids have taught in the past. When they get to school, they give their teachers the software to encourage their colleagues to learn Scratch and then Python and the rest.
Okay, that's a good one. I would want to before you go, I want to critique you further. You've talked about um, government participation. You talked about the private sector. Uh, what do you think um, you need to actually, or what's your kind of vision, and what do you need to fulfill it in terms of that area of what you've been working in?
You mean collaboration with government?
No, yeah, you develop learners, students in coding capacity, right? So
Okay.
now, what are the things that you currently need? Because you would want more of such engagement, and you would want a wider spread of knowledge for young kids. So, what are the things that you think are the necessities that you need right now? Yeah, you've talked about government and you talked about private sector, but now specifically for you right now, and what do you have a vision of something that you wanted to get on?
I spoke about developing an application and writing a book, but I'm looking at having a maker space, at least in Ogun State. like a place where the kid can just come in. Some of the kids, they are very brilliant, they are very creative, but the problem they're having is the enabling environment. So if I have a maker space where they can always come in there. I have so many kits with me, even in my office. I have robot, I have drone, I have, but most time I don't use them. So I'm looking for if I can get a maker space for kids to come together, engage them.
Okay. That's very good. So the idea of a makerspace is really a wonderful one. And uh, if you could get something to do with that, there is going to be more affordances for young learners to actually start to learn coding, practice it themselves, and do a whole lot of wonderful things. So thank you, Mr. Akinode, for being here on the Titaton 24-hour online global conference. And we hope that you're going to get more assistance in the near future to be able to get the bigger space, basically, because I love the idea of the bigger space. Yeah, if you have it, if you get it into a place like Open State, yeah, that would be fantastic. There will be a whole lot of kids that's going to make an impact on. So thank you very much for doing the presentation.
Thank you.
Yeah. So that's Mr. John Akinode, and he's been able to tell us how is turn around the process of doing boot camp on coding and robotics from doing our face-to-face camps to online camps, and how he's been able to engage the learners. And I know we've been able to really get a whole lot from all what we have been, the series that we've been learning uh, in these 24 hours. uh, it can only get better. So we have some exciting uh, guests on the turn of the hour, on the dot of the hour. Yeah, and it's going to be very interesting. Like after this, we're going to still be having some further speakers. So we are still going to be here for the next 8 hours. So can you imagine that? So we still have wonderful presentations from across the world. So we hope that you look up to the 24-hour online conference. So just get on to our YouTube page, our Facebook page, our Twitter page, and it's going to be really fantastic. Thank you very much, everyone. God bless.